In this lecture, I'm going to show you how to use MATLAB to do the block diagram simplification. Let's look at this simple example. First, let's specify the transfer function in Laplace variable s. Then s is equal to TF, means transfer function. Then we can define the subsystems for the overall system. Let's say G1, the subsystem in this block, we call it system G1. The gain is 2. For system G2, it is 4 over S. Then let's define system G4 is 1 over S. Then let's define the gain in the feedback loop is 1. It is a negative feedback. Now let's start with the block diagram reduction. First, let's look at the connection of block 1 and block 2, the subsystem 1 and 2. They are connected in parallel connection. Then we can call the MATLAB command. Let's denote this function, this transfer function, as G3. So G3 is equal to parallel system G1 and system G2. Now let's run this program step by step. We define the Laplace variable s, subsystem G1, subsystem G2, subsystem G4, 1 over S, then subsystem G6, that's 1 in the feedback loop. Now we get the transfer function for the parallel connection of G1 and G2. That is 2S plus 4 over S. We call this subsystem G3. Then this subsystem is G4. We know G3 and G4, they are connected in series. Then we call this system G5. So G5 is equal to series G3 and G4. Its transfer function is 2S plus 4 over S squared. Then last, we know the G5 and G6. It is 1. They are connected in a feedback arrangement. Then we can call the command, this closed loop transfer function is a feedback connection of G5 and G6. Here we obtain the transfer function. It's 2S plus 4 over S squared plus 2S plus 4. So by default, G5 and G6 are connected in a negative feedback. If we want to calculate the transfer function for positive feedback, then we can add plus here. For negative feedback, we can use a minus sign here, but in default, the two systems, if you're not specify the feedback connection, by default, they are connected in negative feedback setting.